welcome to episode 56 of Let's Talk Bitcoin, a twice-weekly show about the ideas, people, and projects building the digital economy and the future of money. Visit us at letstalkbitcoin.com for our daily guest blog, all our past episodes, and of course, tipping addresses. My name is Adam B. Levine, and today we're finishing 0.9. On episode 55 of Let's Talk Bitcoin, we got through digesting the first half of the major upcoming Bitcoin 0.9 update. Today, we kick right back in, talking new, smarter mining fees, and then getting into the meaty topic and major upcoming change generically called the payment protocol. Are you one of the nearly all of us that finds alphanumeric Bitcoin addresses really difficult to use, much less remember? That's one of the problems the payment protocol aims to fix, and it's a pretty big deal. This discussion, Q&A, and explanation occupies most of today's show. I'm joined for the topic by Stephanie Murphy and Andreas M. Antonopoulos. On October 5th, in the wake of the Silk Road arrest, I spoke at the Cryptocurrency Conference about the maturation of the Bitcoin landscape as I see it, why the things that used to mean everything hardly matter at all anymore, and where we go from here. Wrapping up this episode, I've been thinking a lot about some of the memes surrounding the Ripple project and how it compares to Bitcoin. And in a Let's Talk Bitcoin First, I tell you what I think without any guests or co-hosts. Am I coming out of my shell? Did we just have 40-minute long interviews and not enough time to do any of them justice? Really, who can know? Either way, enjoy the problem of Ripple and the liabilities of legitimacy. But first, Bitcoin 0.9 is looking like a beast. Let's finish figuring out what it all means. So the final part of this blog post on 0.9, smarter transaction fees. Again, quoting from the blog post. Today, transaction fees are hard-coded into the Bitcoin QT/Bitcoin D wallet software, and the rules surrounding those fees are a collection of heuristics that evolved over the last 4 years. In short, the current fee handling code is a complicated mess that will stop working as soon as transaction volume doubles a couple of more times. In theory, it should be simple. Transaction fees should be set by a give or take between the people creating transactions, who want to pay as little as possible, and the people validating and storing the transactions, miners who would like to be rewarded with higher fees. And the code that miners are using today to select transactions is simple. They fill their blocks with the highest fee per kilobyte transaction and highest priority transactions if they choose to set aside some space in their blocks for free transactions.
From the early days of Bitcoin, I think the vision was always to make the transaction fees a market, an efficient market where the price of the transaction fee is set through equilibrium between supply and demand. Supply being the miners and demand being the end users of transactions. Effectively, you would have equilibrium at the best price possible on the network at any time, and you can make choices. You know, you pay more, you go faster, you pay less, you get a slower transaction time. That was the vision. Unfortunately, it hasn't yet materialized, but this is a really good step in that direction. Here's the problem with the market dynamic right now. Even though miners are setting a price implicitly by choosing which transactions they put into a block, there's no simple way for that price to be communicated back to the market. So the problem here is price signaling. It's having a way to communicate that market price back to the client so the client can make intelligent heuristic decisions about what to pay for the next transaction in order to achieve a specific time goal. You know, I have a transaction of 10K. How much do I need to pay today to get that transaction verified in 3 blocks by miners? That's the kind of question a client is asking.
That makes sense, but could we just go back for a second? I'm wondering how a miner, quote, decides which transactions to include. Like, how does that work?
Well, at the moment, they use the greedy algorithm, which is they look at all the transactions that are available, they sort them by the number of fees, and they take the ones that have the highest fees per kilobyte. You normalize it on the size of transactions, and then you put those first until you've got a block that's full or full enough to what you want to achieve, and then you post that block. So at the moment, it's basically highest price transaction first or highest fee per kilobyte transactions go in first.
So that's an automated process. And where does that process happen? In a mining pool?
Yes, it happens inside the mining software. Each time you're mining for something, the first thing you do is you create a new block, stick all the transactions in, and then you try to find proof of work against that new block. And you do that every time you're trying to find a block. So that decision happens in building that new block to find the proof of work, and it's part of the mining software.
Thanks for clearing that up.
So miners are really already setting the price. They're setting the price by making a choice, and that choice effectively is the decision of what transactions to include in the block based on the fees that are in those transactions. Now, the question is, how does a client try to predict what's going to happen there? And this is the development has been done in this particular case. I think Gavin's been writing essentially code that uses information from previously mined blocks to try to decide what the level of fees in the network is right now, and to create transactions with the least fees you can pay and get away with the confirmation time you want. And to do that, what Gavin is doing is he's using a historical analysis of transactions in the several past blocks, then taking the median fee per kilobyte, median, not average. That means the point at which half the transactions are more expensive and half the transactions are less expensive. And the reason he picks the median is to avoid gaming by the miners, where they could stuff it, where a few miners could basically rig the game to increase the fees. And the goal is, if you have this simulation done effectively in the client, then it can decide what transaction fees to include with a relatively high degree of certainty that it will achieve its confirmation time goal with that level of fee. And it's relatively hard to game because it would take collusion by multiple miners or mining pools, and any mining pool that broke from that cartel would reap the benefits of competition by drawing all the transactions that have not been serviced. So it's relatively efficient market with good feedback loops, a good price discovery mechanism, and fewer opportunities to game. And it's a market rather than a fixed fee system. So that's the advancement that Gavin's suggesting, and I think it's a great next step towards having a market-based transaction fee.
You know, reading about this really made me think about how Bitcoin compares with the existing financial system. Because, I mean, you could look at what's happening here with how these fees are set in a really similar light to how we use LIBOR as a metric to set rates in the real world and many other markets that are out there, and how, because there are so many people participating in the mining system, there's really no advantage to trying to game the system. Whereas with a closed system like the LIBOR system, where everyone is participating in the regulated environment and you have to be chosen to be on this board, suddenly the opportunity for collusion to try and fleece the people who you're supposed to be providing a service to just goes through the roof, it seems like.
I have the concern that no system can be designed that will not be gamed given sufficient opportunity and market participants who have developed an advantage for themselves within the market. All market systems get gamed eventually. Now, the real advantage with Bitcoin is that even if Gavin sets this market discovery mechanism today and it starts getting gamed, he can change it in the next version of the client and then change it again and then change it again in a very public, consensus-driven approach that has very obvious results in the market. That's what you can't do with LIBOR, because you discovered the scandal 4 years ago, and what exactly has changed in the calculation of LIBOR? Nothing. Markets will be gamed. The question is, do you have the capability to flexibly adapt to that gaming, hit the reset button, and level the playing field again? All of the other systems are too rigid. Bitcoin is flexible enough to do that. That's the key.
So Mike Hearn wrote a excellent FAQ on the Bitcoin forum about the new payment protocol. And basically what this is it's going to change the way that you can send Bitcoin payments. And this is going to take a little bit of explaining. So I'm just going to read through his FAQ. Recently, Gavin merged support for something called BIP 70, 71, and 72 into Bitcoin QT. BIP 70, aka the payment protocol, is intended to be a big change to how people use Bitcoin. A lot of questions come up repeatedly, so here's an attempt to answer the most common ones. What is the payment protocol? Old-timers, of which I am not one because I don't remember this, but old-timers will remember that Bitcoin version 0.1, the first version ever released, allowed you to pay people in two ways. One was by entering a Bitcoin address. The other was to enter an IP address. If you entered an IP address, your computer would connect to the node on that IP and run a rudimentary payment protocol that involved asking the node for a fresh public key, then uploading the payment transaction directly. Satoshi thought that this payment protocol would be how people mostly use Bitcoin. It had some advantages, like guaranteeing a fresh address. He originally intended addresses to be used only for when the recipient was offline, but he was wrong. Addresses quickly came to dominate and hardly anyone used the pay to IP feature. Eventually it was removed. Did either of you guys ever use the IP feature?
Nope.
This must be really old school, because if Andreas doesn't remember it, you guys both don't remember it, and I don't.
This is 2009 and early 2010.
Yeah,
so it's way before most of us.
Yep, yeah, back in the day. So why did it fail? Why did this connecting to an IP address thing fail? One reason is that it wasn't very secure. Anyone who could man in the middle your internet connection, like someone who was sharing your Wi-Fi, could steal money sent this way. Another more practical reason is that back then, there were no online shops that accepted Bitcoin. In fact, Bitcoin was a Windows-only pure GUI, graphical user interface app with no JSON RPC API, a lot of three-letter words, so nobody could even build online shops. So basically, yeah, nobody was accepting Bitcoin in their online stores at that time. So you never knew if the person you were trying to pay would be online or not at the time, meaning giving an address was more reliable. Also, NAT, firewalls, etc. What's NAT?
Network address translation, the fact that many IP addresses are proxied by a firewall or proxied by a router, so you don't have a public address.
The JSON RPC API, Andreas, that's what we were talking about earlier with how most applications interface with Bitcoin?
Yeah, that's the northbound interface of the Bitcoin D application. It's the interface that allows other applications to build on top of it and gives access to the Bitcoin network and system.
So Mike Hearn says but it wasn't a bad idea. So now we're bringing it back, but with a better design. The hope is that over time, this will come to replace Bitcoin addresses for most usages. But don't worry, addresses aren't going to disappear. They'll still be around if you want them. So, okay, that sounds good. I had a little panic when they said this is going to replace Bitcoin addresses. What? But they'll still be around.
I really like that this, this has seemed like it's a theme in 0.9 is that they're adding options, but they're not taking away any options. Is that the way that this is going to progress, where we'll just have things added and, there will be more options over time? Or eventually will some options like addresses, could those be eliminated and removed?
A lot of the code development involves eliminating things just as much as it involves adding things. I think it's an important balance to maintain. You leave too much CRUD from the past in there, then you have to implement it backwards compatibly with everything you ever did in the past. That makes development complex. I think the development team has done a fabulous job of dropping obsolete features when they're obsolete and adding features when they're needed and offering choices where necessary and not offering choices when there shouldn't be choices. It's a very delicate balance, and I think Gavin's done a great job on it so far.
Yeah, it seems like this is a theme. There are more options in this new thing, and that could only be good.
Well, in some cases it's good. In other cases, it is the development group job at some point to make some decisions and then make those decisions happen. Some things are not just about having a choice. Because if you have a choice on everything, then you really have no direction or strategic vision as to where you're going. It's just everything is optional. So right, but I think it's about maintaining, a balance between making decisions and giving choice.
Yeah, I mean, with a feature like how you send payments, and basically that affects how everyday users use Bitcoin. So it seems like that might be a thing that's really important to have options for.
Yeah, absolutely.
So how does it work? It's a way to format a small piece of data, think file, that contains instructions on how to pay someone, a payment request message. Then a formal specification of how to satisfy those instructions by submitting a payment message. The data is designed to be extensible in the future so we can add lots of useful features. In the future, clickable Bitcoin links will look like this. And then he pastes a link that basically says Bitcoin, and then it has a Bitcoin address, and then a question mark, request equals, and then a URL like bitcoinstore.com/product. When clicked, your wallet app will download the request URL and read the payment request it gets. The request message contains another URL, which is where to submit the finished transaction to, instead of or as well as broadcasting it to the P2P network. I need some help understanding that, Andreas. Basically, you're going to click a link, and what happens after that?
I think the way to understand the payment protocol is to think of it compared to the current situation. When you try to buy something from a store, they give you an address. You put that address in your client, and then you create a transaction that goes out on the network and eventually reaches back to the vendor. That's a very loosely coupled transaction. All they gave you is an address, and then you just kind of throw money at it out there in the ether and hope that some of that sticks and the merchant sees that transaction come back to them. This is a much more tightly coupled sequence where it's a 3-part transaction. You ask them, how do I pay you? They send you the parameters of how the payment should be made, where the payment should be sent to. And then you send back to the vendor the transaction sign, the signed transaction itself. Now, that's a key point because for many vendors, if they have a way of verifying the transaction came back and went onto the network, they can even accept it with 0 confirmations. They can trust that it's properly signed. You know, you're not likely to double spend right there, so they can give you a 0 confirmation. Whereas before, they kind of threw you the address and then listened onto the network and hoped that something came back to that address and that it was from you and it wasn't injected as a double spend and all of the other things. It's a much more tightly coupled interaction, which also allows you to deal with problems, right? Because you give an address and then you send a payment, but it's not the right payment. How do you do a refund? Do you need to send more money? Is the invoice filled? Did you get a receipt? All of those types of interactions at the moment are outside the scope of the payment. All you've done is sent an address. Whereas with a payment protocol, all of those could be in scope, could be properly defined. So you could have all of those separate parameters. It's going to make point of sale so much smoother.
That sounds like it's a lot more friendly to merchants who want to use Bitcoin or accept Bitcoin.
And for users too, because keep in mind, up to now, the way to make a payment is copy a 37-character string of gibberish or take a photo of a weird square with dots on it. Whereas the new system is basically telling your client to go to a website and then it does some things in the background and you just get an invoice or a receipt and a payment. So it's going to look much more like a payment system that you know. It's going to be much more user-friendly because you can hide the 37-digit gibberish. You can hide QR codes. You can make it simply about exchanging a URL, which you could do over Bluetooth, over near-field communications. You could do a number of, or with a QR code again if you want.
The first thing I wondered is there a potential for exploitation in this? Like, could somebody basically disguise a link as something that looks like a payment request URL and it's actually a malicious script that steals all your Bitcoins?
Yes. This introduces URLs into the payment system and introduces an HTTP GET. So the clients that do this will have to very carefully process that URL and very carefully process whatever comes from that URL because it's not a trusted system. Really, that's not much different from scanning a random QR code and, hey, let's see what happens. But it's much more explicit. So I think clients that implement this will obviously take the necessary precautions to ensure that any data they receive is not compromised and is not dangerous.
Satoshi Dice, the most notorious Bitcoin gaming site, has unveiled its newest creation, Tribute. In Satoshi Dice Tribute, bets occur off the blockchain for fast and exciting gameplay. Deposit Bitcoins and start playing with 0 confirmations. All bets are provably fair and easily verifiable. Tribute is also social. Players compete with each other, and the top 3 players at any given time receive a portion of the bets from every other player. The rankings reset at midnight, enabling anyone to become the leader with a few lucky rolls. 1% of all Satoshi Dice earnings will be donated to Sean's Outpost. To kick off the new game, the first 1,000 players who lose 0.1 Bitcoin will have that amount automatically returned to them, risk-free. U.S. players are not allowed because America is a free country. The ghost of Satoshi is waiting for you. Find her at satoshidice.com/tribute. Next point from Mike. Who is implementing the new protocol? Support will be in the next Bitcoin QT release, which they say on the blog post that we read previously. It'll be ready when it's ready, so we don't know exactly when that is. And is being worked on for Multibit/Android Bitcoin Wallet, Coinbase, and CoinPunk. BitPay is also committed to implementing it, so all merchants who use their services will get support automatically. If you're planning to support it, let me know and I'll add you here. So they've already got some pretty big names on board with this new protocol. What other features does this add? In version 1 of the protocol, refunds. The senders can submit some refund address to the recipient at the same time as submitting the transactions. Now, if the seller wants to give the buyer a quick refund, they can do so. No more problems with trying to guess the user's address and sometimes getting it wrong due to shared wallets. Bitcoin QT generates a refund address for every payment done this way, but you'll only see them if you actually do get a refund. Memos. Clickable links can already contain short strings or labels, but their length is tightly limited by what browsers will accept and what fits in a QR code. BIP70 allows payment requests to contain arbitrarily long memos, which can be used to describe what you are buying. This is super useful when the payment request is authenticated. And authentication is the next segment, but refunds, that's huge. What they've done, it seems like to me, is built in a feature that allows for a way to give refunds, but preserves, of course, the one-way nature of Bitcoin transactions.
Yeah, exactly. It's not reversible. It's just giving the merchant what is the correct address to send a refund if such a thing should arise. I can tell you, as a merchant in some of the products I sell, I have occasionally had to give refunds, and it's always a manual process. I have to contact the person who made the purchase. If I have the contact details, of course, ask them for a Bitcoin address, send the payment, and then hope that works. This would allow you to pre-arrange the possibility of a refund. And it really shows how you can make this transaction much more tightly coupled. So there's information flowing from the merchant to the customer, but also from the customer back to the merchant if they wish to do so. And behind the scenes, the nice thing is that this can use as many addresses as you want, which means a new address for every transaction without any of the complexity of trying to figure out which address you used.
That sounds great. Now, memos. Would those memos be public, like in the blockchain, or are they just kind of for your own information saying, well, I bought a safe paper wallet kit from Andreas on...
Yeah, this is entirely outside of the blockchain. This is metadata that's transacted during the payment protocol. So it's basically information sent to your client, which will presumably be displayed on the screen, perhaps as a web page, telling you what this payment request is. And it can be much more verbose. So for example, you could have a receipt that has a product name, that has a picture of the product and a price and the tax you paid and all of the other information in that memo. And that will show up on your screen, so you know you're paying the right person for the right product.
But it doesn't necessarily have to be incriminating, perhaps, because it's not public. It's just for your...
This is sent to your client. It could be discarded right after. It's not communicated publicly at all. The nice thing is that this actually continues to preserve privacy and anonymity in terms of not revealing extra information, but at the same time, it allows the clients to fully implement automated recycling of addresses to ensure that they never reuse an address. And that leads to much stronger anonymity. Now, think of it another way. One of the things you could do in a payment request like this is request that the payment be sent to a CoinJoin mixer or shared mixing address. So you could effectively use this to piggyback an anonymization and remixing service on every transaction that goes through a specific merchant by default. That's pretty cool.
Yeah, that is pretty cool. What is authentication about? Mike said in the last point about memos that memos are really useful when the payment request is authenticated. So what is authentication? Bitcoin is a difficult project partly because we're moving money around with general purpose computers that can be hacked or get viruses. Visa and MasterCard have moved everyone outside the USA to special purpose hardware like chip cards and dedicated readers which can't have random apps installed on them. Our approach has to be a bit different, but dedicated hardware is still coming. The Trezor device is a mini computer just for Bitcoin that plugs into a real computer via USB. It has a display and a couple of buttons. It holds your private keys. When you want to make a payment, the details of the payment are shown on the screen, and if they're what you want, you press OK and things get signed. There's an obvious flaw with that design when combined with Bitcoin as it is today. The details of the payment you'll see on the screen will look like this. Pay 0.5 Bitcoin to 1 EZEQ FB blah blah blah. Where did that address come from? Well, it came from your computer, the thing that probably has a virus on it. That virus could have swapped out the address sent by the online shop you're using for one owned by the virus author, and because they're just random numbers, you'd never know. Although the virus can't empty your wallet immediately, it can still steal payments when you make one, and avoiding that is the whole point of using special hardware. The payment protocol allows recipients to sign their requests under an identity. An identity, and identity is in quotes here, is just some arbitrary string that was itself signed by some, quote, certificate authority. The authority then signed statements that say, simplifying a bit, I, Bob Smith, believe address 1EZE ... is owned by Mike Hearn. Now, if your Trezor happens to trust that Bob Smith validates identities reliably, it can display pay 0.5 Bitcoins to Mike Hearn instead of pay 0.5 Bitcoins to this address. And that message can't be tampered with by any virus. As you can see, this is much safer.
The bottom line here is that in this decision, the Bitcoin developers decided to use existing technologies for doing basic identification and certificates. And the technology they're using is SSL certificates, the same stuff we use on the web, X509 certificates they're called, but that's the underlying certificates that are used for SSL. So when you go to eBay.com and you see a little padlock up there, that guarantees that you are, in fact, looking at eBay.com. Without that, someone could basically hijack your session, take you to a site that looks like eBay.com, but isn't. And then when you put your payment information in there, it's stolen. It's a honeypot. In fact, every Bitcoin address can be a honeypot. You don't know anything about it. It's just a random string of gibberish. This will allow you to associate that random string of gibberish to a specific signed certificate and then build some trust around that. So when you go to pay a merchant, you know that the money's going there. And this really makes it much harder to run man-in-the-middle attacks where you substitute a Bitcoin address with another. This is a big problem. Let's say you have a blog at the moment and you want to get someone to tip you. You put an address in that blog, a hacker can come along, hack into your website, edit that page, change the address. How long would it take you to notice that you're not getting any tips anymore? Your tips are mysteriously disappearing into the ether. So it's exactly that kind of scenario that you can solve. In this case, instead of having just an address and text, you would have it assigned as part of the payment protocol. You get a certificate against it. So it can't be substituted without breaking the certificate.
That does sound like it makes things more secure. So how do identities work? Who is actually saying, okay, this is Andreas Antonopoulos? He's saying, essentially, this isn't like a government issued ID or anything like that, or you have to show your passport and tie it to all your Bitcoin addresses or anything like that. What this is essentially anyone can get a certificate attesting to some kind of identity. Often it's just an email address or website domain name. For example, bitcointalk.org has a certificate containing its domain name. It can also be a legal name like Michael C. Hearn or Mt. Gox Limited. In fact, if you have a passport with a chip in it, then you already have a certificate containing your passport data, but it's not very useful because there's no private key attached to it. Sometimes certificates are paid for and other times they are free. The certificate authorities never get your private key. Instead, you generate a private key locally, then ask the certificate authority to sign your public key. At the same time, you prove your identity. If your identity is an email address, then you typically receive a clickable link there, for instance. If it's your name, you might have to submit some paperwork. But if it's your forum name or something like that, you probably don't. Basically, what he goes on to say is there's probably going to be a marketplace of certificate authorities that evolve, and they're going to be offering different levels, some free, some paid for, of certificates that are attached to different sort of facets or aspects of your identity. So this is not something that makes Bitcoin less private or less anonymous. It doesn't have to be your legal name, your legal identity at all. It can totally be something like a forum handle or an email address.
And keep in mind, this is for the merchants and the merchants who choose to attach an identity to their payment addresses. This isn't for the end users. You don't need to have a certificate as a buyer or as a client or as an end user, because you don't need to prove to anyone who you are when you're sending money. You only need to generate trust when you're receiving money. So this really affects merchants. I think the smart move here was to piggyback on top of the X509 SSL certificate structure, because right now, if I want to get a domain or an email address certified, I can choose from 30 different certificate authorities, from VeriSign to Network Solutions to some of the smaller and cheaper ones, and they can produce a certificate that's widely trusted. They have the infrastructure for doing the verification, and it's relatively robust and has been already used as the foundation for SSL. So it's a really smart move because it leverages existing technology nicely.
So then he goes into talking about why can't we use the PGP Web of Trust, which is basically I don't really understand it that well, but PGP is a way of encrypting emails and communications and other things. And the web of trust is when people validate and sign each other's keys, that certain keys belong to certain people. There used to be, or maybe still are, some things called key signing parties where people will meet in person and say, oh yeah, this person is who they say they are. I can verify that their key actually belongs to them, and I'm going to sign their key. And then it creates this web of trust, which is a bunch of people who have confirmed that they all are who they say they are. And you can kind of tap into that web of trust to verify people's ID. It's kind of technical and a little bit on the longer side, so maybe we won't go into that. But Mike is saying that it's really not possible to combine the PGP web of trust, nor would they want to, with the new Bitcoin protocol.
I think that this also gets into the question about should the perfect be the enemy of the good? Because that's essentially the other argument that Mike is making here is that, yes, there are some problems with the existing SSL certificate of authority system, notably that sometimes certificates get issued to people who shouldn't have them, and that sort of taints the whole thing. And so he lays out a couple of improvements that could be applied to the system as it is now. But really, that's the primary thing, is that this is an incremental step towards something better than where we are now. Is that right?
Even if SSL has had some flaws, it's got broken, there's issues with the certificates, it is by far the most successful broad-based deployment of encryption the world has ever seen, and probably the most effective security and privacy tool that we have ever deployed. I think the primary reason is really simple. As a user, you don't make a choice to use SSL. It just happens. And that's a key element of security and why SSL has been so successful. The burden is shifted to the merchants who have the funds and the motivation to do it, and the users get it automatically without asking. That's a really good security model. And, despite all its flaws, it's been the most successful encryption we've ever had. So it makes a lot of sense to use what already works on a global scale.
So it sounds like there's a lot of stuff coming in 0.9.
Yeah, it seems like generally this is being pretty well received so far, at least by the comments on the forum.
I'd like to point out that also, I don't know how much meaning to read into this, but 0.9 is a pretty significant version number in itself. The decision to go to versions that start with a 0.9 is really important because that means we are now heading head on to the 1.0 release of Bitcoin. That's the next step. Essentially, these are the release candidates and betas that will lead to the first official version 1 release of Bitcoin. So it's an important milestone to hit 0.9. The exciting development in Linux happened between 0.90 and 0.98.
My name is Adam B. Levine. Like I said before, I do a twice-weekly show called Let's Talk Bitcoin. It's really important that we solve the problems that are in front of us, because there are a lot of problems. I think that they're solvable, and so that's actually what I wanted to kind of talk about here, is how we're solving some of these problems and how it's happening in a way that doesn't require permission, which means that it's happening really fast. Things move fast in the world of cryptocurrency, and since I started Let's Talk Bitcoin in April of 2013, we've seen regulatory compliance that completely reversed the compliance landscape. Companies come and go, and we've seen the conference scene completely explode with at least one a month and sometimes as many as 4 a month happening all over the world. Over the last few days, we've seen the apparent demise of the Silk Road, the ubiquitous Bitcoin illegal stuff market, and the arrest of the man accused of operating it. And the price just was crushed. And then it wasn't. Why is that? Mt. Gox, right? The elephant in the room when it comes to centralized Bitcoin exchanges. In the crash and the week-long freeze about 2 years ago, some of you might not have been in the community at that point, but there was complete chaos. Nobody knew what the price of a Bitcoin was, and most people had their Bitcoins tied up. It was a terrible situation. Because the single exchange serviced a huge majority of Bitcoin's transactions, It was both an incredibly lucrative operation, but also a huge central point of failure for not just trading Bitcoin from one currency to another, but how we get the price in the first place. Bitcoin Talk. For a long time, it was the Bitcoin community. It was the place where people went to meet the community, to educate themselves, and to kind of dig into this project that we call Bitcoin. A couple of days ago, it was hacked, and when I checked it this morning, it was still down. There are a few similarities between these three events. First off, they're all controversial sites. They're ubiquitous, but everybody loves to hate the front runner. And amusingly, the Silk Road of those three companies probably has the best reputation. They also don't matter. Now, a year ago, 6 months ago, this would have been a very different conversation, a much more depressing topic. But the free market's at work here, and while in the past these events would have crushed their various niches, and that's contraband for Silk Road, price and liquidity for Mt. Gox, and community and thought leadership for Bitcoin Talk, their success actually catalyzed and incentivized the next generation. So what we're seeing is that these high-profile, ubiquitous, and in their own way centralized operations are arguably just as dangerous to their users as new players. They may have more reputation, but that makes them a more tempting target for both bad actors, just as it does for new users. Even in these fields we view as dominated by one or two players, increasingly that won't be the case. These things don't matter anymore because there are alternatives that are just as good, if not better, in their offerings who've been waiting for that vacuum left by the failure of what have become our legacy institutions, are too big to fail. Except in a monopoly-free system like Bitcoin is, there's no such thing as a too big to fail. And really, these are companies that are just standing there as almost roadblocks where they have this momentum. And the momentum with a big company a lot of times is enough to keep you going and enough to keep your customers happy because there's a cost to switching. But that's not the way that things are going to go. These institutions were the first, but they're not the last. You know, Silk Road has 3 or 4 similar competitors who are already fighting over their customers. Gox is arguably less impactful now than ever for the price, as far as most people are concerned. And you know, I mean, my favorite price source is Bitcoin Average right now. I think that the guys at Invictus Innovations are working on a very interesting pricing model, but right now I'm still using BitcoinAverage.com, and it actually has a button up there that you can select that completely excludes Mt. Gox from the price list, from the pricing equation. And of course, Bitcoin Talk, you know, I mean, Bitcoin Talk for the longest time, that was the only place that you could talk about it. And now, I mean, Reddit surpassed them. I think they have about double the number of users. And if you've gone to Reddit in the past couple of days, you've probably seen it's going actually really slow because most of the people who are still on Bitcoin Talk have moved over. You know, that might be a temporary thing, but it's definitely happening. So the point is that where there used to be one voice howling against the wilderness, we don't live in the wilderness anymore. The entire ecosystem and Bitcoin and cryptocurrency are growing up right before our eyes, and it's happening really, really fast. I'm privileged to devote nearly all of my time to cryptocurrency, and I've really never been more excited than I am, you know, in these last couple of months. I think that we have a lot of challenges ahead of us, but mostly mostly it's permission-based. So it's been said before, the US has a choice in front of it. We can choose to embrace this technology and see the future and be a vital part of building it. Or we can do everything in our power to try and make it so this is hard, and we'll probably do a good job of stopping it from legitimate uses in the United States. And then get left behind. So the problem with open source projects a lot of times is that there's too much availability of workable solutions that don't do the job in a way that's accessible to people. This is especially true with the Satoshi client, I think. We're just now starting to see these newer wallets come out that really can leverage and take advantage of just some of the basic usability work that's been done over the last few years. So these problems are going away. You know, there's a wallet that's coming out called the Hive wallet that really has a focus on usability and kind of, again, tries to continue this trend of amplifying the Bitcoin experience where anybody can, you know, immediately get in. This is sort of a buzzword, but it's really not this hipster thing. It's what needs to happen. We need to focus on usability. For buying products, BitPay is a major player in the space. But at the same time, they weren't trying to reinvent the wheel, as Tony said, when it comes to how we buy things with Bitcoin. So to this point, most merchants accepting Bitcoin use that standard shopping cart flow, where you add a product to your cart, and when you're finished with all of your shopping, you enter your billing information, pay the total with either a credit card or via Bitcoin. But really, Bitcoin doesn't need anything like that.
It's a workaround created to address problems associated with identity, because that is, of course, as has been discussed, how our money works. You have to associate identity, acquire authorization or permission, and then you're allowed to withdraw money from that, essentially. But with cryptocurrency, since the holder is the owner, we don't need to do that anymore. And I think that our payment solutions aren't going to require it of us, because it isn't actually helpful at all. It actually creates more of a risky situation than you have if you don't do that. Shameless plug here. Let's Talk Bitcoin has a crew that is filming this event, and we're selling video passes. And if you go to bitcoinvideopass.com, then you'll see our first implementation of what is called the Bit Credits system. The creator is a gentleman named Alexander who lives up in Canada, and he's been working on this for the last couple of months. It takes a look at this problem that we have of needing to associate identity, and it rethinks it from the cryptocurrency standpoint. Occupying about 1/3 of the page, and with the explanation text wrapped around it, you don't actually ever need to leave that page in order to make the payment. It just has a little interface up there, and it prompts you for the amount of money that you're going to put in US dollars. It gives you that amount, and then it tells you how much it is in Bitcoin. And you can essentially load this up with Bitcoin, where then we take on the exchange risk and give you back website credits that are denominated in US dollars and can buy anything on our system. You know, technically this talk is called Doing Business with a Deflationary Currency, and people think this is a big problem, because who wants to spend Bitcoins when they're hard to acquire and will gain value over time? There has to be a compelling reason, and after my experience with this Bit Credits thing, I want to share my trick with you. Charge people more who pay in US dollars. You can call it a discount for your Bitcoin price, or you can call it a surcharge for your dollar price, but if you want people to part with their Bitcoins for whatever you're selling, you need to take into account the future value of Bitcoin, because your customer certainly is. And if the mental math doesn't work for them, they're going to pay you in dollars, because why shouldn't they? For our passes, we offer between a 20% and 30% discount, and found that our sales are about 95% Bitcoin. Now, obviously, I do a show called Let's Talk Bitcoin, and we only promoted these to our audience, but, you know, my experience has been that when I'm trying to buy something, I spend a lot of Bitcoin. We receive funds from our sponsors in Bitcoin, and we receive donations from our listeners in Bitcoin. And so when I go to spend, it really is a value equation for me, where I'm saying, okay, is it worth it to me to part with these Bitcoin, knowing that at a later date they're going to be worthwhile? And generally, I kind of demand like a 30%. Whenever I'm doing services with someone or hiring a designer or something like that, the discount is generally at least 30%. Sometimes it's a lot more. Bit Credits is one option, and I like it a lot because it essentially lets users play the market against Let's Talk Bitcoin. When they buy our on-site credits, all the volatility is removed from the equation. We denominate credits in US dollars, so you can make one transaction on the Bitcoin network to load up your wallet, and any commerce you do on the site is instant and transaction fee free. Right now, you can only buy these passes, which incidentally are heavily discounted over at our table over there, for attendees of the conference. But within the next week or two, we're going to roll it out to the entire site. And this is interesting because our show is supported by a mix of listener donations, about 75% of which come in at just under $1. So even in a Bitcoin paradigm, if you have transactions coming in that are under $1, and you have to pay a fee that's somewhere between 6 cents and 25 cents, by my math, it's usually about 6 cents. Then that actually winds up being very expensive, and it's almost, you're right back up there with credit cards. So there are, of course, drawbacks. By doing this, we essentially take the transactions off the blockchain, and we centralize the records of value on our servers, which means that to a certain extent, we have responsibility to protect them. But again, we don't have to collect hardly any information. For digital goods, we literally only need an email address. We don't keep the funds on our server. We don't keep the keys for our funds on the server. They go into essentially a black box, and then we pull them out. But there's no way to access them through the server directly. Eventually, the system is going to go both ways, and the people who write for Let's Talk Bitcoin, when they receive tips, they'll receive these credits that they'll then be able to cash out at whatever the exchange rate is at that point. So the entire time that we're holding, we've taken on that exchange risk. And I think that that's something that is really attractive to a lot of operations like ours, where we do have costs. I'd rather pay my costs in US dollars, and I'd rather keep my tips. It's really what it's come down to. So there are, of course, others who are trying to find this prize. The barrier to entry is really low here, and the payoff for whoever nails this content monetization question is going to be really big. So there are some other people who are doing good work in the area, specifically the bitwall.io people have a paywall application that's very interesting, and then Bitmonet, which is in partnership with BitPay. And I've been trying to get together with them to learn more about their project, but I haven't been able to make it work yet. So even this is a stopgap for where we're going. Projects like Watershed or eGora, which you're going to be hearing about more in the weeks and months to come, are creating frameworks to build new communities and economies entirely on top of, with cryptocurrency baked in at an infrastructure level. And I'm especially excited about a project called NetBank that, again, I want to learn more about, but you can think of it like a simplified cryptocurrency infrastructure that lets those wanting to build any kind of complicated service that involves a lot of money routing around or going to various places to essentially plug it in kind of like you would with a little starter circuit board where like all the underlying wiring's there, you just plug in the various modules that you want. In expertise, as with everything else, cryptocurrency is a meritocracy. The people who are up here as experts, generally speaking, are because they want to be. Because they're passionate about the future we can create, and instead of waiting for someone to tell them what to do, they followed in Satoshi's footsteps and just did it. I've got a saying I've been saying a lot. It doesn't matter that I do this now, but in 6 months, it will have mattered that I did it 6 months ago. I think that Bitcoin, that's really it in a nutshell. Everything is so positional right now, and to mix metaphors, we are arranging lounge chairs while the tsunami approaches, bringing with it a very different and hopefully a much better world. Thank you.
Hi, listener. Here at Let's Talk Bitcoin, we're building a global network of correspondents able to contribute on-the-ground perspective when cryptocurrency-related information comes across their filters. If you'd like to join our global conversation, send an email with your name and geographic or cultural niche to apply@letstalkbitcoin.com. Just like Bitcoin, the only barrier to entry is your time and good work. Thanks for listening.
EasyDNS is the Swiss Army knife for your domain names, helping meet their customers' individual needs since 1998. EasyDNS has been an outspoken critic of SOPA and CISPA. EasyDNS was an early supporter of Bitcoin, and now they are proud to sponsor this show. Do business with a company that shares your values. Get a 13% discount when you pay with Bitcoin. Go to bitcoin.easydns.com and be sure to use discount code LTB.
As a guy on a show called Let's Talk Bitcoin, it comes as no surprise I think Bitcoin is the bee's knees so far as digital currency options are concerned. Recently, I sat on a panel at the C2SV, the Converge Create Silicon Valley conference, and one of the other experts on the panel was Chris Larson of Ripple Labs. He said a couple of things that I disagree with. First, that Ripple is Bitcoin 2.0. That's a bit of an odd thing to say. And second, that if you can get law enforcement on the side of your currency, you'll have won. For those of you not familiar with the Ripple system, it can be thought of as a parallel development to Bitcoin that tries to solve many of the same problems. Bankless money transmission to anywhere in the internet-connected world. Ripple goes about solving the problem slightly differently. There are no miners, transaction validity is determined by a cascading consensus engine. Ripples themselves, XRP, were fully pre-mined and initially owned by Ripple Labs. They aren't really traded as currency themselves, so this isn't as much of an issue. Instead, they're intended as an anti-spam mechanism, like a stamp on an envelope with a check inside. This piece was published on Let's Talk Bitcoin the day before I recorded this to release on the show, and one of the early comments pointed out that the Ripple project has actually been under development since about 2004. And if you go back to that 2004 page, then right there on the front of it, it says, "We want to make your promises as good as a bank's promises," because essentially that's what they're saying, is that when a bank extends credit, they're extending a promise to pay. In the Ripple thought process, the thing is, okay, well, if we have the infrastructure to issue these credits just amongst people, then why do we need the banks in order to facilitate that same sort of transaction? Ripple ultimately looks like it was designed to maintain the functionality of the banking system while removing the banking system itself from the equation. So they're both trying to solve this problem, but it really is kind of fundamentally at odds how they're trying to do it. Bitcoin does it through an ownership, person-to-person based system, and Ripple is built on interconnected network of P2P credit. Bitcoins are wholly owned with no risk of the redeeming party defaulting, but with Ripple, that is a risk. The Bitcoin system transfers ownership of one thing, Bitcoins. People can build layers on top of it to do other things, but at a protocol level, it's just Bitcoins on the Bitcoin network. But what if you don't want to send Bitcoins? This is where Ripple is really a good option. When you send US dollars through the Ripple system, you're really sending IOUs that can be redeemed somewhere else in the system. Depending on your need to transact in non-Bitcoin terms, this might be important. Or you might prefer the wholly owned nature of cryptocurrency. And this is getting to be an interesting thing. as we move towards a more pervasive Bitcoin future, we're starting to see a Bitcoin ecosystem develop where you really can get all of your needs met without ever touching a currency besides a cryptocurrency. And right now, this is more true for Bitcoin, but I think that as we move forward, we're going to see these infrastructures develop where the cryptocurrency particulars don't matter. And it's just cryptocurrency is accepted here, and whichever one you happen to use, there's an exchange rate based on that, based on this market mechanism. Now, I don't think it's fair to say that Ripple is Bitcoin 2.0. I really think it's more like a parallel evolution that brings its own strengths and weaknesses to the table. It better fits the needs of some, and it's worse for others. But there's no question that if Ripple had matured before Bitcoin came into use, we'd be having a really similar conversation, and it would be just as wrong to have called Bitcoin Ripple 2.0. One of the liabilities that Ripple has all to itself is a corporate structure. They make the argument, as will Invictus Innovations when they launched the BitShares protocol, that just because a company designs, creates, and releases a protocol into the wild doesn't imbue them with any responsibility for any disruptions that protocol might cause. Satoshi didn't disappear because of all the appreciation that was sure to be showered upon him. Rather, the risks of standing alongside such a disruptive thing was sure to generate a bad outcome. Maybe not for Satoshi, but somebody loses in that scenario because there are entities and individuals to whom pressure can be applied. It's tempting to want law enforcement on our side. They're scary folks doing a difficult job. I used to have an unreasonable amount of respect and awe for the people who apply our justice system, but over the last few years, experience finds that diminished. I see more arrests for petty crimes and no enforcement of the law where the most egregious violations have taken place. Finance. Ultimately, there isn't much question here. In Bitcoin, barring a registration process that sees public keys issued to specific names, I don't see how you tell the signal from the noise on anything but specific cases. In Ripple, I don't know, but I'm pretty curious. It's also not surprising that Ripple Labs takes this approach. What choice do they have? If they're seen as aiding or enabling illegal activities, they have facilities that can be raided, assets that can be seized. Look at how law enforcement deals with media piracy. Anything a payment network would be guilty of is, of course, worse. We live in strange times, but some things are so powerful and dangerous that to sign your name to them is tantamount to suicide. Maybe not for you, but for the goals of the project. No reason why a pressured company has to die if instead they comply. With money, the issues are always permission, not technology. Thanks for listening to episode 56 of Let's Talk Bitcoin. Content for today's show is provided by Stephanie Murphy and Andreas M. Antonopoulos. Music was provided by Jared Rubens. Any questions or comments? Email Adam@letstalkbitcoin.com. See you next time.